गुड मॉर्निंग बच्चा। मैं ऑडिबल। Okay. So today we will start our discussion with capacitors. Before starting, I will say one thing that this is the time to practice a lot of questions. If during the classes you have noted down anything, you have noted down the questions, then try to solve it out again and again. Try to solve those questions again and again. And if you face any problem, then go through the solutions, go through the videos so that you can get exact idea, because we have discussed a lot of questions, the test paper that you have taken, the discussion, the PYQ questions that we have discussed during the classes. So please go through it and you will get, definitely you will get a lot of questions from those discussions. So today we will start with capacitors. First thing is, this is the content that we're going to study in this class. One thing is, what is capacitance? Capacitance, everybody knows, is the ability of a conductor to store charge, the capacity of a conductor to store charge. One thing that everybody knows, that charge on a conductor is directly proportional to the potential difference, or you can say Q is equals to CV, where C is a constant of proportionality and is called as capacitance. So the first statement is Q is equals to CV. From this very statement, what we can conclude that this is the golden relation that you should remember, first thing. Next thing is, C is the constant of proportionality. And if you see, if we draw the graph between charge and potential, if we draw the graph between charge and potential, that is very common. This equation resembles the y is equals to mx equation. Y equals to mx equation means this is an equation of straight line. So graph will be a straight line passing through the origin. This is the graph of Q versus B. Next thing is, the slope is a constant. Slope is constant. Another thing, this slope represents capacitance. Slope represents capacitance. And slope from which side? From potential side. From potential side. Is it clear? Now, after knowing these things, one thing that we should focus slope from the potential side, from this side. Now, another thing, more slope means is equivalent to more capacitance. Very good. Another thing. Now, one question that is very common, and the question is, from this relation you need to answer. And the question is, if charge on a conductor is increased, if charge on a conductor will increase, what will be the change in the capacitance? What will be the change in the capacitance? Can you answer? If charge on a conductor is increased, what will be the change in the capacitance? Will it increase, will it decrease, or will it remain constant? Increase, decrease, or remain constant? What will happen? Which is correct? Anyone? Veena? So from that point of view, you can say that C is equals to Q over V. And if you increase Q, then one thing that you should uh, keep in your mind, that C is a constant of proportionality. The amount by which Q increase, the potential will also increase, and the capacitance will remain constant. And these two things are not going to happen. Remember one thing, whenever the charge on a conductor is increased, its capacitance will remain constant, because C, you can see here, is a constant of proportionality and it is constant. If you increase Q, then V will increase. In the same way, if potential is increased, then still C remains constant. In both the cases, capacitance will remain constant. Whatever you do with charge and potential, capacitance will remain constant. Is it clear in your mind? Moving further. Now there comes a conductor. Capacitance of a spherical conductor, mark my word, this is only a spherical conductor. There is a single conductor. And what will be its capacitance? Its capacitance is 4 pi epsilon naught R. 4 pi epsilon naught R, where R is the radius of the conductor. Or you can also write 4 pi epsilon naught is nothing but, you can say it is 1 by R, 1 by Ke. It is 1 by Ke, so it becomes R by Ke. That means C is directly proportional to R. Capacitance is directly proportional to R. Another thing that you can say here, that capacitance is the property of size and shape. It depends on size and shape and not depends on charge and potential. Is it clear? Okay. Moving further. Now there comes a parallel plate capacitor. What is parallel plate capacitor? The two plates you can see here are placed parallel to each other. These two plates have some charge. Let's suppose it is charged positively. It is minus Q, plus Q and minus Q. It has some area A, and the separation between the plates is D. So the capacitance of a parallel plate capacitor is A epsilon naught over D. I think you can remember this relation, A epsilon naught over D. So again, you can see capacitance depends on geometrical parameters. Depends on geometrical parameters, and its unit is, anybody knows unit is farad, denoted by capital F. Generally, you will see microfarad and nanofarad, sometimes picofarad. Microfarad means 10 to the power minus 6. Nano means 10 to power minus 9. Pico means 10 raised to the power minus 12. These are the prefixes. C is equals to A epsilon naught over D. Remember this relation. Clear? I hope it's clear. Moving further, next thing is, which is very important, is the force. This question is directly asked a lot of times. This is plus Q, this is minus Q, and they are asking what will be the force between the plates, how much force the plates will exert on each other. So one thing is that this is positively charged plate, this is negatively charged plate. So the force will be of attractive nature. Force will be of attractive nature. Clear? What will be this force? Q square over 2A epsilon naught. Q square over 2A epsilon naught, where A is the area of the plate. A is the area of the plate. I think it's clear. Remember the formula, write down the formula. They are very useful. Q square upon 2 epsilon. Now, one more thing that I will tell you. This is positively charged plate. This is negatively charged plate. So there will be an electric field between the plates. And this electric field will be from positive plate to the negative plate. Clear? This electric field will be from the positive plate to the negative plate. What will be the magnitude of this field? So I will write field between the plates. Field will be due to two plates at any point. At any point, different plates. One is positively charged, one is negatively charged, and this field is sigma by epsilon naught. Remember this word, this field is sigma by epsilon naught, where sigma is the surface charge density. I think you remember that sigma is the surface charge density, and surface charge density, it can be written as E is equals to surface charge density means charge per unit area. This is surface charge density and epsilon naught. And this field is from positive plate towards the negative plate. This is an important thing that you should remember. Clear everything now? Force is of attractive q square by 2a epsilon naught. Moving further. Energy stored in the capacitor. Let's suppose there is a capacitor. There is a capacitor. This is plus q, this is minus q. Separation is d. And the potential that is applied across its two ends is delta V. So there is a field. There will be a field E. And you know this field. What is this field? Sigma by epsilon naught. Now the energy stored is half C delta V square, where delta V is the potential difference across the capacitor plates, half C delta V square. It can also be written as Q square by 2C. Remember, either one of them, it can also be written as U is equals to Q delta V by 2. Can also be written like that. You can transform these into each other. No problem. Remember one of them, at least one of them. You should remember this one at least. Now the thing is where this energy is stored. So this energy is stored in the form of field. This energy is stored between the plates in the form of, this is energy I have written, form of electric field. And this is known as electrostatic energy. This is known as electrostatic energy. Mark my words, this energy is electrostatic energy, is stored between the plates in the electric field. Clear? Moving further. Now there comes dielectric. Dielectric is what? Kind of insulating material. Insulating material. I'm going very quickly so that you can get important points. Insulating materials. Maybe made of polar materials, maybe made of non-polar materials. Maybe made of polar and non-polar. Do you know the meaning of polar and non-polar? What are the polar molecules? What are non-polar molecules? Do you know that? Non-polar molecules do not have permanent dipole moment. Dipole moment is denoted by P, and polar molecules have permanent dipole moment. This is the difference. Now, the next thing that I will discuss here, listen to me very carefully. This is a non-polar molecule. And this molecule has some positive charge and negative charge, and both these charges will coincide. The center of gravity of these charges will coincide. Let's suppose this charge, this molecule is placed in some external field. So by the effect of external field, positive charge will be repelled in the direction of field and negative charge will be repelled in the direction opposite to that electric field. So it will become something like that, positive and negative. So this was non-polar and it has become polar by the presence of electric field. Clear? I hope this point is also clear. Whenever a non-polar molecule is placed in uniform field, is placed in field, it becomes polar. Next thing, what if I say that I have placed a polar molecule, negative, positive, in the external field E? Can you see that this is a dipole? Negative and positive, can you see this is a dipole? And dipole has a dipole moment in the direction of negative to positive. So this is the dipole moment. In electrostatics, what we have seen that whenever a dipole is placed in uniform field tries to align itself in its own direction. That means this molecule will be rotated and will get aligned in the direction of electric field, negative, positive. Can you see that? Field is this one, dipole moment is this one, and these two are aligned with each other. So this is what happens. I think every point about it is clear. Now, one more thing. This is the topic that we are discussing, the molecules. Now, what if a complete slab is placed? What if complete slab is placed in an external field? Let's suppose this is a dielectric slab. It may be polar, maybe non-polar. So I am just drawing it something like that. These are polar molecules. And they are oriented in different directions, whatever the direction may be. Negative, positive, negative, positive, positive, negative, negative, positive, whatever you see. Okay, this is the dielectric slab. Now I kept this slab in the external field E. What will happen? This field will align all those molecules in its direction. So everyone will be aligned and it will look something like that. Very systematic it will look. Every molecule will be arranged something like that, very keenly. Negative, positive, negative, positive, negative, positive, external field E. So in the process, what will happen? At the left face of the surface, there is some negative charge in, and at the right face, there is some positive charge. Due to this, some electric field is induced. This is induced electric field, EI. Original field, let's suppose it is E naught. Original field, let's suppose it is E naught. And some field is induced, that is EI, from positive to negative. Now, can you see that net field inside the slab is decreased? Net field inside the slab will decrease and it will become something, let's suppose E. Outside is E naught and inside is E. And it is somehow decreased by this induced field. By this induced field. So, one thing that we should remember that whenever a dielectric slab is placed inside, or whenever the dielectric slab is placed in a field, the field inside it decreases. The field inside it decreases. And one more thing that is very important here, one term, that is dielectric constant. Dielectric constant. It is generally denoted by K. What will be its value? K is original field divided by reduced value of field. E is what? Reduced value of field. E naught is what? Original field. So this ratio is called dielectric constant. Clear? This ratio is called dielectric constant. I think it's clear now. Now, after clearing these things, what we can conclude? Whenever a dielectric slab is placed in a field gets reduced. Field inside the slab gets reduced by the original value from the original value, and the ratio of original field to the reduced field is known as dielectric constant. Clear? Moving further. Now the thing is effect of dielectric on capacitance. Effect of dielectric on capacitance. Can you see that if I say there is a capacitor, these are the capacitor plates plus Q and minus Q. And between these plates, some dielectric is being filled completely. This is some dielectric, which is completely filled like this is K. So the capacitance of this system will become A epsilon naught over D is the capacitance when there was air. It is multiplied by K. K is the dielectric constant. So it becomes A epsilon naught K over D. Or you can say capacitance in a medium is K times capacitance when air was between the plates. And this is the case when dielectric was completely filled. Now there comes a case of partial. Can you see that? Capacitance increases. Capacitance increases because K was greater than 1. K was greater than 1, so capacitance increases. So now if partially filled, so you can see in this diagram, the separation between the plates is D and the dielectric which is filled is T. So now can you see that what will be the capacitance? A epsilon naught over D minus T plus T by K. Again, I will say capacitance is decreasing. Again, capacitance is decreasing. The remaining portion is air. Air. Clear? Okay. One more thing that you should remember. I think everybody knows. K for air is what? 1. Dielectric constant for air is what? 1. Is it clear? Remember this thing. Now, if you want, I can make you understand one more thing here. If you can learn that capacitance is decreasing, you can see. Now, the important thing that I want to explain here may be of something difficult level. This is some dielectric of dielectric constant K. And this outside area is A with the dielectric constant 1. Clear? The air has a dielectric constant 1. Now, can you see that? Can you write 1 here? No problem. So identify the situation A epsilon naught divided by, you can see T upon K. T is what? Thickness of the dielectric divided by its dielectric constant T by K plus D minus T is what? D minus T is the thickness of the air. Can you see? If the total separation is D, dielectric is T. So remaining portion is air. Remaining portion is air. So D minus T is what? Thickness of air divided by dielectric constant of air. Divided by dielectric constant of air. Can you see how to write A epsilon naught? Now this situation can be drawn in a different way, and I hope you will answer that. Let's suppose this is a capacitor plates Q and minus Q, and there is a dielectric inserted. Let's suppose this one is a dielectric and this one is another dielectric. This is very common problem. We can solve it using two methods, but one method that I am telling you is very simple. Let's suppose this dielectric constant is K1, this is K2. This thickness is D1, this thickness is D2. Clear? Or you can say T1, T2, whatever you want. So if I want to write the capacitance of this system, again listen to me very carefully. Capacitance of this system, how to write? A epsilon naught is in the numerator. A epsilon naught divided by what I'm saying, thickness of the medium divided by its dielectric constant. Thickness of the medium divided by its dielectric constant. So thickness of the medium is what? D1 divided by K1 plus D2 divided by K2. Can you write it this way? If there are three dielectrics, then you can write it D1 by K1, D2 by K2, and D3 by K3. Is it possible to write for you? Can you solve it? These type of questions are very much visible in your exams sometimes. Multiple, this is a case of multiple dielectrics. I will tell you later in the next slide. I hope there is a type of question similar. Okay. Let's suppose this is D1, this is D2. So I hope you can write. In this slide, I will tell you another approach to write this. I will tell you another approach. Okay. So that you can know how to write in different situations, how to work with different situations. Is the first situation clear? Say yes or no. Is this first situation clear from here to here? After that, I will move to the next slide. What you should remember, A epsilon naught. Okay, very good. So moving on to the next slide. Now the another approach that we can take here, that will also be beneficial for you if you can understand that. Remember, I hope you know that series and parallel combination. The interface of the two dielectrics. Now, at the interface, I'm telling you in short actually, this is the interface of two dielectrics. So this forms, this is not Q, this is Q. This forms a capacitance. Let's suppose this is a capacitor of capacitance C1 and this is a capacitor of capacitance C2. What I am saying, that the dielectrics are filled parallel to the plates in this way. All the dielectrics are placed. So at the interface, there are separation. It can form two capacitors. One is C2. So can you see that capacitance C1 is A epsilon naught by D1. This is the capacitance and the dielectric constant is K1. Similarly, C2 can be written as A epsilon naught K2 by D2. These are the two capacitors, and can you see that these two capacitors are back to back connected, and if they are back to back connected, they are in series. They are in series. So for series combination, you know that, I hope, for series combination, C1 and C2 are in series. So 1 upon C equivalent is equals to 1 by C1 plus 1 by C2. I hope you remember this relation. So you can solve it out. 1 by C is equals to 1 by C1. If I say, it will be D1 by A epsilon naught K1 plus D2 by A epsilon naught K2. You can take something common. 1 by C is equals to 1 by A epsilon naught is common. It will be D1 by K1 plus D2 by K2. So if you calculate C, it will be reversed. So you can solve it out and we will get the same result as we have got here. You can see that we will get the same result. So this is the way you need to learn the way. What is the way when they are placed in this situation? These are the two capacitors. You can write the capacitance of each and they are in series. Now in the same way, when they are placed in this way, When the dielectrics are placed perpendicular to the plates, this is again C1, this is again C2. Let's suppose the difference is, you can understand the difference. Can you see that this dielectric, there is one capacitor of this one. At the interface, this is one capacitor, this is another capacitor. The plate has a area, total area A. This portion has a area A1 and the below portion has a area A2. The separation between the plates is D, and both of these capacitors C1 and C2 have same separation. So what you can write? You can write capacitance of first capacitor is A1 epsilon naught K1 by D. Similarly, C2 is what? Area of the plate is A2 epsilon naught K2 by D. Now these two capacitors are connected in parallel because the potential across both the capacitors is same, so they are connected in parallel. If they are in parallel, so C equivalent is equals to C1 plus C2, and you can add them directly. If you add them, then what you will get common, that is epsilon naught by D will be common. It will be A1 K1 plus A2 K2. This is what you get. So I will not recommend you to remember the relation. This is not recommended. What you should remember the process, that when they are placed in this situation, the area of the plates will get changed for each capacitor. It may be given that it is A by 2 and A by 2. It may be given in the question. It may be A by 4, 3A by 4, whatever may be the area they will give you. But the thing is, they will be in parallel combination, and in this situation, the capacitors will be in series combination. I think it is clear. I think this is not to be of very much importance. What is the combination of capacitors? Series combination identification is what? Can anyone tell me? I told you in the class of resistors, that is back-to-back connection. Remember this line, back-to-back connection without any junction. Without any junction. So they are connected back to back and there is no junction between them. So this is the series combination. And one more thing that I will tell you, in series combination, charge remains the same. Charge remains same in all the capacitors. Clear? One more thing, the parallel combination. When the capacitors are connected between two same points, like this is A, this is point B. Okay, very good. Very good, Chichini. So C equivalent can be written as product upon sum. Very good. You can remember it as product upon sum. This is valid for two capacitors only. In the case of three capacitors, it will change. One more thing, if you are asking, then I will tell you one more thing. That if n identical capacitors, for n identical capacitors, C equivalent is equals to C by n. Each capacitor has a capacitance C. So it will be C by n for n identical. For example, I say three capacitors, each of 3 microfarad are connected in series. So equivalent capacitance will be, can you answer me? Three identical capacitors, each of capacitance 3 microfarad are connected in series. What will be their equivalent capacitance? What will be their equivalent capacitance? Can you answer? C by n, I told you 3 microfarad divided by how many capacitors? 3. So that will be 1 microfarad. That will be 1 microfarad. Clear? Moving further. I think parallel combination is done. Okay. Now there is one more very important type of question. Okay, before moving that, can you answer me what will be the Subhash Chandra Singh? Yes, beta. Can you answer me one thing that what is the energy stored in the capacitor? What is the energy stored in the capacitor? Can anyone write the formula? Just okay. Half CV square. Very good, very good. Remember, Chichuni, it's a half CV square. Energy stored in the capacitor is half CV square. Now, the type of question that I am Array. The type of question that I am going to discuss. Okay, okay, Subhash. Remember one thing. There is a type of question. What is the type of question? That there is a capacitor and this capacitor is connected with a battery. Clear? Remember the question. Capacitor has a capacitance C and it is connected with a battery like that. Now, they will say two things. There will be two scenarios. One scenario is that they will remove battery. They will remove battery and insert the dielectric between the capacitor plates. Clear? One is battery they will remove and insert the dielectric between the capacitors, between the capacitor plates, and add dielectric. Next situation, what is going to happen is they will battery remains connected or you can say battery remains connected and they will add dielectric. In both the situations, dielectric is being added. But in one situation, battery is being removed and in one situation, battery remains connected. Now, what will be the change in the quantities? Like what will be the change in capacitance, charge, potential, and energy? You should remember this thing. Now, first thing that you should remember, पहली बात जो आपको याद रखनी है, that is, if battery remains connected, then potential will remain constant. So you will write in that situation, potential will remain constant. So new potential is equals to the original potential. One thing that is to be sure. Because battery maintains the potential across the capacitor. If battery remains connected, that means potential will remain same. And if you insert the dielectric completely, then capacitance will become K times in any situation, whether battery is connected or not. Capacitance will become K times. This is the type of question. According to this, lot of questions can be formed. I think two things are clear. Now, if battery remains connected, then new charge will change and it will become K times of original charge. It will become K times of original charge. Energy will become K times of original energy. Now, can you know that what is the value of original charge? You know that CV, Q is equals to CV. Original energy is half CV square. Now, if battery is removed, this is the situation when battery is removed. There is no battery and dielectric is inserted. Capacitance becomes K times. The amount of charge that was stored already on the capacitor cannot go anywhere. If it cannot go anywhere, that means the charge will remain constant. So in this situation, new charge will be constant and it will remain constant as Q. Remember these words, remember this table. The potential will be V by K. Energy will be U by K. Energy decreases by K times, potential decreases by K times, charge remains constant, and capacitance becomes K times. Remember this table. This is going to be a very important table for you. Moving further. Can you note it down? Why charge is constant? Okay, listen. Charge is constant. This is the capacitor. It already has some charge Q. Clear? This was the battery that is being connected and there were no dielectric between them. This is the original situation that I will say. This is the situation. Now I removed the battery. As soon as I remove the battery, I have removed the battery. You can see that battery is removed. So the charge stored on the capacitor cannot go anywhere because there is no way where it can go. Are you understanding my point? I have packed something which is isolated. So this charge has to stay here because this side there is no way. This side there is no way. So where this charge will go? This charge cannot move because the connection is lost. So in this situation, the charge will remain constant. Are you getting my point? So why charge is constant? Because it becomes isolated system. It becomes isolated system. And for isolated system, charge is conserved. Clear? So this is conservation of charge. Moving further. Now we will take some questions very quickly. Veena and Chichni, do you know Hindi? Somewhat. Okay, you both know Hindi. Okay. Okay. So next time we can take it in Hindi as well, na? Okay. So the electrostatic force between the metal plates of an isolated parallel plate capacitor C having charge Q and area A is. I think you remember the force. Anybody remember the force? That is Q square by 2A epsilon naught. I think you remember it correct. So the option is it is independent of distance between the plates. It seems good. Linearly, this is wrong, wrong, wrong. So which is correct option? It is independent of separation between the plates, distance between the plates. There is no term of D. Very easy question. Another question. Question says the capacitance of a parallel plate capacitor with air as medium is 6 millifarad. 6 millifarad. Okay. So capacitance with air is 6 millifarad. Next thing is with the introduction of a dielectric medium, the capacitance becomes 30 millifarad. So now they are saying capacitance with some medium, it becomes 30 millifarad. The permittivity of the medium is. So they are asking the permittivity of the medium. So now you can say that C in a medium or capacitance when dielectric is filled is A epsilon naught K over D. Clear? This is the capacitance of air. So you can write it again. C is equals to C naught times K. I think you remember this relation as well. C is equals to C naught times K. So K is what? C by C naught. C is 30. C naught is 6. That is 5. So dielectric constant is 5. Now you want to calculate the permittivity of the medium. What is permittivity? Now you know that K is equals to epsilon upon epsilon naught. So permittivity of the medium is K times epsilon naught, and you can place the value K is 5, epsilon naught is 8.85, 10 raised to the power minus 12. Can you multiply this? Can you multiply this? 5, 5, 25. That is 44.25 into 10 raised to the power minus 12. 44. So, okay. So, out of this, which option is going to be correct? I think option C is correct. We can transfer decimal by 2 points. Very good, Veena. Now, again, the question is same. What is the question? Two parallel metal plates having charge plus Q and minima. I mean, they are talking about capacitors, each other at a certain distance between them. If the plates are now dipped in kerosene oil tank, the electric field between the plates will. I hope I told you that this is the capacitor, this is the plus Q, this is minus Q, and the field between these plates is from positive to negative, and the magnitude of the field is sigma by epsilon naught. Clear? Sigma is Q by A, obviously. Sigma by epsilon naught, this is the field. Now, if some dielectric is filled, I told you, whenever there is some dielectric between the plates, or when there is the dielectric is placed in external field, the field gets decreased. The field gets decreased, or you can say new field will be sigma by epsilon naught times K. So it will be decreased. So decreased means option number C is correct. Moving further. Before going to that question, solve this question. Uh, this question. Solve this first. I will explain the question. A capacitor is charged by a battery. Okay, so there is a capacitor. Let's suppose this is the capacitor, and this capacitor is charged by a battery. Okay. The battery is removed and another identical charged uncharged capacitor is connected in parallel. Now listen, first of all, let's assume the potential of the battery is V and the capacitance is C. This is the initial situation. Now what they are saying, that battery is removed and another uncharged capacitor is placed parallel to the first one. So this is C, this is C. Identical hai, so both the capacitance will be same. Now, the total electrostatic energy of the resulting system, they are talking about the energy of the resulting system. So before explaining these things, I will explain you one more thing that I can explain here. This is a blank sheet. Okay. One thing. Let's suppose this is a capacitor C. It is charged by some battery. Before moving to the question, learn something. By some battery V. Then how much charge will this capacitor have? How much charge will this capacitor have? This capacitor will have a charge Q is equals to C into V. This is the amount of charge that this capacitor will have after some time. Clear? Now the question says, this battery is removed and another capacitor is placed. Battery is removed. Let's suppose this is C1. So this is C1V. And another capacitor is connected. This is uncharged. This is uncharged. And this was already charged. You can see that by this battery, this was charged. Now what will happen? Charge will be transferred from first capacitor to the second until, mark my word, until the capacitance of both the capacitors will be equal. Until what I'm saying, okay, remove everything. Until the potential of both the capacitors will remain equal or will become equal, I will say. I must say that charge will be transferred. Charge will be transferred among them until potential become same. Until the potential of both become same, the charge will be transferred. Clear? In the same way, there might be two conductors. This is conductor 1, this is conductor 2. This is having Q1 charge, this is having Q2 charge, having potential V1, having potential V2. If these two conductors are connected with the wire, then let's suppose in that situation, the charge will be transferred from one conductor to the other until the potential of both will become same, and charge will be transferred from high potential body to low potential body. So remember one or two things: high potential to low potential charge will transfer until it becomes same. Is it clear? And this potential is known as, potential becomes same, this potential is known as common potential. This potential is known as common potential, and this common potential is given by using the formula Q total by C total. Q total means total charge, C total means total capacitance. This is the case when one capacitor is uncharged. One capacitor is uncharged. Now coming back to the question. I think this was the question. Now listen. Initially potential is V, capacitance is C. So you can say that initial energy is half CV square. Is it clear? Now, when an uncharged capacitor is connected, so there will be a concept of common potential. So that V common potential is what? Total charge over total capacitance. The charge on this capacitor is CV. Charge on this capacitor is CV. This is uncharged. It has a charge CV. So total charge is CV divided by total capacitance is C plus C, that is 2C. It can be cancelled. So that is V by 2. New potential is what? V by 2. So this capacitor has a potential V by 2 and this capacitor has a potential V by 2. So we can write final energy. U final is energy of first capacitor plus energy of second capacitor. Energy of first capacitor is half C V common square plus second capacitor half C and V common square. So can you see that it will become C V common square? that is C, and V common is what? V square by 4. So new energy will become CV square by 4. Original energy is CV square by 2. Can you say that it becomes half? So U final is U initial by 2. So what is the correct option? It is decreases by a factor of 2. Decreases by a factor of 2. So which formula you should remember? V common, total charge over total capacitance. Now try to solve this question in your homework. This is the similar question, exactly similar question, but the language of the question is somewhat different. So you can solve this question. So I am ending the session here. Bye everyone.